Hello everyone, welcome to Noisebridge. This is the Python class. It's a free class that happens every Monday at Noisebridge. We are on lesson 2, though it's not the first time that we've taught lesson 2. This is the second time. It's a repeat. We're trying to repeat some of the lessons as we go through this series of the class. So today we are going to be talking about some of the more building blocks of Python, some keyword and syntax for flow control. So if statements, we'll talk about some Boolean variables and operators. We'll talk about for loops, and then if we have time, we'll talk about list comprehensions. So the first thing we learn is the if statement. So an if statement in general is provided to conditionally execute code. So you execute the code if something is true. So here we have x equals 30. If x plus 2 equals 5, it prints x is 3. Otherwise, it prints x is something other than 3. So we can see here that 30 plus 2 does not equal 5. So it should print x is something other than 3. Let's see. Yeah, it does. If we change x to 3, which is I think what it was supposed to be, and run it again, x is 3. The basic kind of makes sense just logically. If this is true, print this thing. And here's another example. X equals boo, result equals scary. So we check if the length of x is greater than 4, the result is not scary. If the length of x is greater than 5, the result is still not scary, and it prints the result. So what do we think this is going to print? I heard not scary. Any other guesses?
Scary.
Scary, yeah.
Yeah, it's scary.
Does anyone think it'll print still not scary? No? Alright, let's see what it prints. It prints scary because, oh yeah, because x is boo, so the length of x is not greater than 4, it's 3. It's also not greater than 5, so none of this code in these blocks executes, this code doesn't execute, this code doesn't execute, and so the result remains what it originally was, scary, and it prints scary. So notice that as opposed to the first example where we had an if-else, if statements don't have to have else statements attached to them. And now this is kind of like, if you're thinking about how this works, this top example is almost the same as this bottom example, right? Because it does run this code, this if condition, like the Python interpreter runs this code, like it checks the length of x, compares it to 4, etc. But because those if statements are false, it's almost as if they don't exist, right? It's like, that never happened. We just print the result, and we print scary, like we saw. So we can express truthiness, which is an actual term, and falsiness, which is also an actual term, with Boolean variables. A Boolean variable is a variable that has either the value true or false. So here's a kind of long example, but basically, is raining equals false, so like we're saying, oh, it's not raining outside. Is going outside equals true, so we're saying like, okay, you're at your house, but you're gonna go outside. So basically what we wanna do is, in this example, we wanna like print a message based on whether it's raining or on whether you're going outside or not. So here we have some variables here, need umbrella, need exercise. These are also Boolean variables because they're set to false. And we initialize them to false because until we know better, we just assume, okay, you don't need an umbrella, you don't need exercise. That's the default value, right? Then later we check, if it's raining and you're going outside, then you need an umbrella. Need umbrella now equals true. Else if, right? This is an else statement combined with an if statement. So otherwise, if that first thing wasn't true, otherwise, and if this other thing is true, not going outside, then need exercise equals true. So at the end here, we set another Boolean variable, printed something equals false. Now, if you need an umbrella, it tells you need an umbrella, and printed something is true. If you need exercise, it tells you need exercise, and printed something equals true. And then if not printed something, so if the opposite of printed something, which means that if printed something is false, we haven't printed something, then it'll print have a nice day. So let's look through this example and try to figure out what it's going to print. So we have is raining equals false, is going outside equals true. So if is raining and is going outside, so are those both true? No, right? Is raining is false. So it's not going to do this part. Else, so that was false, so we're going to do the else. Else and if not going outside. Not going outside? No, going outside is true. So not going outside is false. So then need exercise is not going to be equal to true. It keeps its default value of false. Then we go down to the printing part. Need umbrella. Well, it started as false. We didn't set it to true, so it's still false. So none of this code runs. Then need exercise is false by default. We didn't set it to true, remember? So it's not going to do any of this. So what it'll print? Have a nice day. Because printed something was false. So did we not print something? Yes. Not printed something is true. I feel like I'm not making any sense. Okay, run it. Have a nice day. Okay, let's change it to it is raining and we're going outside. So now is raining equals true, is going outside equals true. So we run through the code again. If is raining and is going outside, are they both true? Yes. Is raining is true, is going outside is true. So need umbrella equals true, right? We're setting the value of need umbrella to true. That's a Boolean variable. Now this part, else if, wait a minute, we're not doing an else. We're not doing an else if because we did the original if. We ran through the code in the if block, so we skipped the else and the else if. So then we get back to the printing part. We default to printed something equals false. But need umbrella is true now, right? So if need umbrella, so it's going to print you need an umbrella. And then it's going to set printed something equal to true. Do we need exercise? No, because that was false and we never ran this code. We didn't run the code in the else. So now, if you didn't print something, it's going to print have a nice day. So is it going to print have a nice day? There's two options, yes or no. Just you got a 50% chance of being right on this one. Is it going to print have a nice day? No, I hear a no. Why not?
Because it's going to print need umbrella.
It's going to print need an umbrella, and then printed something is going to be true. So not printed something, the opposite of printed something, is false. So this is going to be like if false, which means it doesn't do it, right? It's not going to print have a nice day. So this should print you need an umbrella. Okay, it prints you need an umbrella. Good. And now let's try one more time. False. So we run it one more time. Is raining is true, but is going outside is false. So this whole thing is false because they're not both true, so it's false. So it doesn't say need an umbrella. And else, not is going outside. Is going outside is false, so not is going outside is true. So we enter this block and need exercise equals true. Then when we go to print stuff, we say if need exercise, which we just said is true. It's going to say you need to get some exercise. It's printed something, so it won't print have a nice day. So this should just print you need to get some exercise. And that's what it prints. Yay. So I'm going to put these back to the original values so I don't forget. Okay. So one important thing to realize about this is that if the code for a condition, the code that for conditions that aren't true gets skipped. So like back in this example here, like if len is greater than 4, not scary, right? Remember we said it's basically the equivalent of this because this code never runs, right? So it goes actually a bit further than that. Like that code in that if or else block, which doesn't run, can contain like invalid code. Like you see even VS Code is like yellow squigglies here. Like food does not exist is not defined. Like yeah, no shit, right? Like, and then here I'm trying to divide by 0. But if I run this code, it just prints 99, right? Because n is 99. Is n less than 100? So it prints n, which is 99, right? It didn't even try to run any of this code. And it didn't ever, because it didn't try to run it, it didn't realize that it's garbage code that produces errors. If I change this to like 990, and I run it again, now I get an exception. Food does not exist, is not defined, this part, right? And then if I comment that out, now I get division by 0, right? Right here in the 5 divided by 0, right? So it's just kind of good to keep in mind because you might have some code that's like, oh, my code is working, everything is great, sunshine and rainbows. And then like you run it with some different data or you test it a different way and suddenly it's executing an if block that wasn't being executed. And suddenly your code crashes. And you're like, how is my code crashing? It wasn't crashing before. What happened? It's because anything that's in an if block that isn't true doesn't get executed. Does that make sense? Cool.
What did you do to get division by 0? I'm sorry, I said that.
Oh, I just, the question was, what did I do to get division by 0? I just commented out the first error, and it went to like the second error. Oops, and I also had this equal 990. So is n less than 100? No, it's not. So it prints 5 divided by 0, but when it goes to do 5 divided by 0, obviously that's an error. Okay, here we go. This is a fun exercise. Who did this exercise last time we were in this lesson? I think maybe some people, some familiar faces. Anne, you might have done it. You did it? Yeah, okay. Did you do it too? Okay, we'll come up with a separate exercise for you guys. And people who haven't done the exercise yet, you can try this exact exercise, which is we're going to write some code that takes a variable named num and prints it is big if it is greater than 100, and it prints it is really big if it is greater than 1,000. And you should test your code with different values of num. So you're going to start off with like num equals 5, if num something, blah, 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 right? Stuff like that. Cool. And let's come up with another exercise for people who have already done this exercise. Give me 1 second. Alternate exercise. You just get a glimpse into my mind here as I try to think of an exercise on the fly. We should do something with strings. Okay, let's do this. Let's try write some code that takes a string s and it starts with an A or Z, prints a different word. I'm just talking to myself. Okay. All right. For did I spell exercise wrong? Yeah. Exercise. Okay. So for the folks who have already done the big num exercise, here's a new exercise. So we're going to take a string s. I should say like try your code with different values for s. Okay. So the alternate exercise is we're going to assign a string to the variable s, and then we're going to use the starts with method to check if the string starts with an a or a z, and if it does, we'll print out another word of your choosing that starts with that same letter. It's pretty simple. There's nothing tricky. It's just, cool. All right, I'm going to come around and check on the results of the exercises. All right, so I'm just gonna have to pull it back together at this point. We've got a lot of stuff to get through. So here is this one. So here's my solution to this. If num is greater than 100, print it is big. Oops. And then if num is greater than 1,000, print it is very big. So that's basically the code. And then this exercise is kind of funny. We got into this in previous lectures. Where we have like 150, then it prints it is big, right? Because it's greater than 100. But if we put like 1,500, it prints it is big, it is very big. Which technically, that's what the assignment was, right? Because it's greater than 100, so it prints it is big, and it's greater than 1,000, so it prints it is really big, right? But some people, I think, when they read this, they thought it was like counterintuitive. They thought it would be more appropriate, like if it only printed one message. It didn't say that in the assignment, but some people thought that was what it should do. So we can try it like this, right? So what's going on here? I said if num is greater than 100, print it is big. Else if num is greater than 1,000, print it is very big. So what's wrong? Why did it print it is big instead of it is very big? It's both, exactly. It's both. 1,500 is greater than 100, so it prints it is big. And then like I was saying, with the else, any else or else if does not get executed if the original if got executed. So then it doesn't even go through this code. It is very big, right? So there's a couple of ways to make it print only one message. So we can say, first of all, we can check like if it's greater than 1,000, print it is very big. Otherwise, if it's greater than 100, print it is big. And this would be like the number is less than 100 if we got here, right? So we do that. Now it actually works kind of more intuitively, right? Cool. I'll leave that up for a second. And then the alternate exercise, so this one is even more simple. So basically say like s equals arithmetic, and we say if s starts with a, and I'm going to print apple. If s starts with z, print zebra. So I run this, it prints apple, Zelda, and I print zebra. That's all I was looking for. Cool?
I thought you were like, generate a word that starts with the same letter. That's why I was like, I don't know how to do that.
It starts, no, only if it starts with an A or a Z.
Yeah.
That starts with that same A or Z. Maybe that'll make it easier to understand for next time.
That's pretty cool.
Yeah. Okay, and then, this is kind of hard to like put into words, this next part, but it's also kind of intuitive, so maybe it's not that difficult to understand. So like variables other than booleans can also have a true or false value associated with them. That's why I was using the words truthiness and falsiness. So for example, the number 0 is a falsy value. Any number other than 0 is truthy, represents truth or true, but 0 represents falsy or false. So here we have 100 is a truthy value, right? So, and then lists that have values in them are truthy. Lists that are empty are falsy. And so if I run this code, we see that it says num truth is truthy. So that's this. Num truth is truthy. It didn't print num is truthy, right? Because num is 0. And then fruits are truthy because my fruit list contains fruits. Empty list will not print. List is falsy. I should put that here. Okay. And then num truth and fruits both are truthy. Cool. Good. Does that make sense? Is it like 0 is false and anything else is true? Empty list is false, any other list is true. Empty dictionary is false, anything else. It's kind of like you're thinking about like writing a program that was like, oh, give me all of the computers that are ready to print or something, and it gives you back an empty list. You could say like, if print list, and if it's empty, that's false, right? Like there's nothing to print. That's kind of how it's designed. And like, yeah. It's kind of a holdover from other languages, to be fair. Oh, and then this one I saw, this whole section was added from when I did this lecture 3 weeks ago. Everyone seems to want to write if A equals true, right? You don't need to write if A double equals true. You can just say if A. Because if it's true, then, if true, and it prints it. A is truthy, right? So you just run this code. A is truthy, A is true. Yeah. There's nothing like erroneous about writing if A double equal true. But you'll find later when we have like multiple conditions that we're testing, it gets like really verbose for always this like double equal true all over the place, right? So mostly we just want to do if A. Yeah, and this is exactly what I'm talking about, right? Like if we had this like if is raining, double equal true, outside, double equal true, on playground, double equal false, double equal true. It's like, what is all this nonsense? It's way too much. You want to just write if is raining and this, not that, done, Okay, so I went through this last time. I feel like I can go through it a little bit faster because it's kind of just intuitive. Like, I don't think I need to get into the full technical definitions of all these operators. But basically, we have and, or, and not are the primary Boolean operators. And we already saw and for a second, right? We saw and. We haven't looked at or much yet. But so let's say I have these Boolean variables. Well, actually, let's do we should do the truth table first. Okay. So here's the truth table for and, right? The top row here is the value of A. The column is the value of B, right? So if A is true and B is true, then A and B is true. If A is false and B is true, then A and B is false. That's just like a lookup table, right? So if you look at this table, you see that with the and operator, and it should probably have yeah. So for the and operator, it's only true if they're both true. They both have to be true to make it true. For or, if either one of them is true, it's true. So it's only false down here in the bottom right corner when they're both false. When A is false and B is false, then they're false. Then or is false. And not is just one dimensional because it only takes one Boolean. Not true is false and not false is true. So not a variable is the same as what it was, right? Like not true is false. So not true is true, right? Yeah, double negatives, who knows? All right, let's see. Let's try to run through some of these real quick. All right, so all the ones that start with T are true. All the ones that start with F are false. And these go from left to right. That's the precedence. So it goes left to right. So when I have all of these on the same line like this, it evaluates these two first, and then the result of that plus the next one, blah, blah, blah. And then everything in parentheses first, and then the results of it. You know what I mean? So, so T or F, true or false?
True.
True. All right, so that's true. True or true? TA. True or TA? True. Okay, then true or FA? Still true. Okay. True and false. False. And then the false and true? False. So this should print? False. Let's see. False. Great. We did it right. It can be easy to be tripped up on some of these, so. All right. T or F?
True.
True. And TA, which is true. So true and true. So this should print true? Prints true. Great. Now this one, here comes the final boss. All right, so we have nested parentheses here. So we look at these parentheses first. True or true. And then we have to do this one next. False or true? True. So then true and true? True. Okay, so that's true. And then we have parentheses over, well, we do these ones first. So this is true or false? True, yep. And true or false again? Still true, yep. And then true, oh, we have to go to the parentheses now. True and true. True. And this whole left side was true, so true or true? True. All right, let's see it. True. Yay. Okay. Well, truth tables. All right, now here's the exercise. Oh, I don't know. Did I put the answer in the notebook? Is the answer in the notebook? It looks like it is, right? That's too bad. I'll have to come up with a new exercise. And some people have done it already anyway, so we have to come up with a new exercise anyway.
No, mine gets an error.
When you run this?
Yeah, I might have changed it or something.
This runs fine for me. Okay, so let's come up with a new exercise. Actually, let's come up with a new exercise using the same data. So let's say, so we've got this t-shirt and these pants. What do we want to do? We want to say like, okay, so we want to say like, let's write new code that says if the item is between $10, okay, let me write it out here. If the item is between 10 and $19.99, the discount is 10%. If it's greater than $19.99, the discount is 20%. And what else do I want to say? There's not much else I can do with this. Okay, and then if on sale is true, yeah, there we go. Let's do that. All right, so everyone's notebook has this in it, right? With the check sale method already written?
Yeah.
Yes. Okay. That's a mistake, but we're going to roll with it. So now we're saying, let's write a new function. We're going to call it alternate discount. It takes an item. And so what we want to say is, if the item is between $10 and $19.99, the discount is 10%. If it is greater than $19.99, the discount is 20%. And if on sale is true, you take an additional 5% off the final price. The final price. So you apply the first discount, and that's the final price. You take another 5% off, right? And then let's say we want to print the name of the item and the final price. Final total. So here we have like this, we're going to create this method called alternate discount. I just put pass here. I think we talked about pass a little bit. It's just like a no-op Python statement. It just means like placeholder, basically. Does this new assignment make sense? It's very similar, but there's like slightly different conditions you have to check. I keep saying assignment. It's like an exercise, you know? Does that make sense for everybody? Yes? So I ended up writing an alternate exercise anyway, right? Okay, so here's the alternate discount. So basically we say like if item price is greater than or equal to 10 and item price is less than 20, discount equals 0. Otherwise, if it's greater than 20, the discount is 80%. Otherwise, the discount is full price. There's no discount. Then if the item is on sale, first we have to calculate the price. The total equals item price times discount. And if the item is on sale, we give another 5% off. And then we can say item name is on sale for total. Let's call it. See what it prints out. T-shirt is on sale for $10.68. Does that make sense? It was $12.50. We took 10% off, so $1.25. That seems right. Is that right? Yeah? Okay. All right, so yeah, some people were trying to I saw some people trying to get this on sale thing to get bunched into these if statements. But it's not necessary, right? Because you're applying this first discount, and then you're doing a separate if statement to apply the additional discount. So you don't need, like, not every if statement in your program is going to be one big if statement, right? Like, that's kind of the lesson, So cool. And I'll try to remember. Well, I should delete these now so that they don't get saved into. Okay, so they don't get saved into the notebook. All right. Oh, this reminder was for that exercise. Oh, go ahead.
Yeah, so just one question. Is there a way to have all these items in one dictionary, or do they all need to be separate because they have values?
Yeah, good question. The question was, is it possible to have all the items in one dictionary? Yeah, we can have all the items in one dictionary. So we could have, say, like, store equals, we have, like, t-shirt, and I can put let me do, like, pants, and it's like this. Does that make sense? So then how do I get the price of the pants if I have the store? How do I get the price of the pants? Oh, it told you, basically, but so I just store pants, right? So that's, if I say store slice pants, that gives me this dictionary, right? And if I take that dictionary and slice for the price, cool?
Yes. And could you still pass that through the function?
You would need to,
Function?
yeah, so if you had a function that was like def get discount item, I'm going to use pass because I'm not going to actually write the function. I could do like get discount store pants, right? And then that store pants is this dictionary, which is like the same as what we were using before. Cool?
Thank you.
Yeah, no problem. I'm gonna delete this so it's not just get saved. Sorry. I reuse the notebook, so I don't want to like. Sometimes I accidentally put the answer to the exercise into the saved notebook. Here's some stuff that should have been before the exercise. Just showing you how to get the values of the dictionaries. And then we already talked about this. Oh my God, the playground. Here we go. Wow. All right. We're going to breeze through this because I don't even like this example. Okay. I'm sorry. I write these examples and I'm like, wait, this is so convoluted. Like, it's impossible to explain. But all right, basically we've got some kids on a playground, kids and adults on a playground. We want to determine who gets ice cream. The logic is, if you deserve ice cream, if you're under the age of 12, and you have to be in the park to get ice cream, right? So I have this function, deserves ice cream. It checks if you're under age 12, then yes, you deserve ice cream. Otherwise, you don't. And then this is just, I'll talk about that in a second. And then here we have another one, are you in the park? If the location is playground or the location is picnic, then you're in the park. And then later it says, if deserves ice cream, Alice, and is in park, Alice, then ice cream for Alice. Otherwise, carry on, Alice. And it does the same thing for Bob, because it defined all these people, Alice, Bob, Claire, Dennis. These are tuples. We'll talk about them in a second. So this is the basic thing we're working with. So let me run this code. Okay. So then it prints carry on 35 playground because that's what the variable Alice refers to. Notice the name Alice doesn't appear anywhere here. And carry on 55 gazebo because that's what the name Bob refers to. So then this was supposed to be an exercise, but it got pasted in. We'll ignore it. Yeah, so tuples. So these things here are tuples. They're like lists, except they're immutable. I covered them last time we had this lesson. Basically, like, this is a food list. Notice that it has square brackets here, right? This is a food tuple. Notice that it has parentheses here. If I want to go shopping with my list, I can add cereal to the list. And I print it, and now it has cereal in it. If I try to go shopping with the tuple, it doesn't work because tuples are immutable. They can't be changed after they're created. So a tuple is like a list, except you can't add or remove any items. That's all it is. That really is all it is. Back to ice cream. So this is where we introduce the for loop, right? Because we're saying, like, okay, we've got this list of people, and in our case, the list is 4 people long. But, like, you know, maybe you're running a website that has like millions of users, right? And you have like 1,000 people that need to check if they get ice cream for some reason. Geticecream.com or whatever, I don't know. So you're not going to write this code over and over 1,000 times for all of your users, right? We need some way of saying, like, okay, take each user one by one and run this code for that user, right? And that's what a for loop gives us. So when we have the same tuples as before, except now, well, not the same, because now we've added their names as the third part of the tuple. Then we have this tuple, everyone, which contains these variables, so it contains all of these tuples. Did I run this? Yeah, okay. And then here's the for loop. For person in everyone should get ice cream person. So if I run this, I get carry on Alice, carry on Bob, ice cream for Claire, carry on Dennis. So what's going on here? No, just remember that this should get ice cream method is this method here that just basically does the if deserves ice cream, print ice cream for blah, otherwise print carry on, right? So what's going on here? Everyone is a tuple of tuples. So when I say for person and everyone, it takes that tuple and it takes the first thing in it, which is Alice. It assigns it to the variable person. Then it runs all of the code in the for block, right? So the should get ice cream. So that says carry on Alice, right? It gets to the end of here, right? And says, okay, is there anything left? No. Okay, time to go back to the top. Who's the next person? It's Bob, right? So then we run this for Bob, and it prints carry on Bob. See where I'm going with this? And then it gets to the end. All right, start from the top. Now, Claire is the person, right? Should get ice cream Claire. And it says, yes, ice cream for Claire. And then it gets to the top, and it says, now the person equals Dennis. Because we just did Claire, now we're on to Dennis. It says, should get ice cream Dennis, carry on Dennis. And then now what is it going to do? It's at the end of the list, right? So it gets to the bottom here, and what does it do? It says, okay, there's nothing left. We're done. And it goes on to here. After Dennis, we get here, right? It's done with the for loop. It's gone through every single item in the list, or tuple, or whatever it is, and now it's done. And then it prints done, which we see here. Immediate questions about for loops? No? Okay, makes sense a little bit already? Yes? Okay, good. And then this text here just kind of explains what I just explained. So here I can count how many people get ice cream. I do deserves ice cream and is in park. Ice cream for that person's name. And I do count plus equals 1 because I got ice cream, so I add to the count. So basically it says it goes through each person, checks if they're getting ice cream. If they are, we add 1 to the count, which started at 0. And then the count equals 1, so the noun is person. Otherwise it would be people. That's just, a funky thing to do. And then, wow, 1 person got ice cream. Just another example of using a for loop. Okay. Cool. I want to go back to this. So like when you're first learning how to use if statements and functions, you might write a function that looks like this. If age less than 12, return true. Else return false, right? What you're really saying is if this is true, return true. If it's false, return false, right? So really, I can just return age less than 12. Because I'm saying, if this is true, return true. Well, it is true, so you're just returning it, right? If it's false, return false. Well, I'm just returning whatever it is, right? So I know you'll probably feel safer and more comfortable writing it this way as you're starting out. But just know if you see this, it's the same thing. Because age less than 12 is what we call an expression. That's from last week, 2 weeks ago. So yeah. Okay, here is, all right. We have a file with some data. What is this data? Who knows? It's letters and numbers. I don't know what it represents, but we're going to process it. So we can open the file and split it into lines. So this is, we did some of this in the first lesson with open as file. As I've been saying, that's kind of just, you have to memorize that for now, as that's the way we open files in Python. Then I'm going to read the file, and then I'm going to split it into lines. Basically split, each line becomes its own item in the list. So if I print the lines, I see I get like D10, B5, which is what's in here, D10, B5. So each line became an item in the list, okay? So now I can write a program that prints all the lines that start with A. For line in lines, right, that's all the lines. It's going to take each line and sequentially assign it to the variable line. If line starts with A, print line. So if I run this, I get all the lines that start with A. So this is, again, remember the header here is using if and for together, right? All right, now we'll take it a step further. We're going to split the lines on space because they're separated by a space. There's a letter and a number separated by a space. So if I call dot split with a space, I'll get a letter and a number. So here we see letter number as string equals line dot split space. And then my total, I'm adding the number as a string, but turn it into an integer. This is the syntax for like, I've got the string 50, but I want the number 50. So I take that string and I call int on it to coerce it into an int. When I run this, total for A is 270. Pretty cool, right? And you see here, I can print out letter number as string. It's printing out all the wait. Does that make sense? Questions? Yeah, go ahead.
There's an F, and then, hang on. Print close open parent, F, apostrophe, phrase, then close apostrophe. What is that, F?
The F? Yeah, it's called a format string. So it's pretty simple, actually. All it is that, like here, I want to print the I'm keeping track of the total, right? It starts at 0, I'm adding to it, then I want to print it. Anything within these curly braces in an F string, the result of evaluating that Python code gets printed. So let's just do some examples. So I do like fruit equals apple. I do like print F, the fruit is fruit. It prints the fruit is apple, right? Because everything in the braces, this is the variable fruit, it gets replaced with apple, right? If I do price equals 5, and the price is price, right? Makes sense. But I can put any Python expression in here. So I can do like, now it says the price is 10 because I did price plus 5 in there, right? And I can even use things like, I think I still have an item. Like I can use a dictionary access in there, right? Like whatever I want to put.
Can you put
Good.
like a tuple in there?
Yeah, I can put a tuple in there.
And what would happen if you removed the F? Would it still print?
It would print, but it would print literally this
Yeah.
without replacing the values.
Oh.
See? Okay. So run this again. Okay, total for, all right. And like again, think about what's the difference between 2 and the string 2, right? One's a number, one's a string. They both have a 2 in them, but you can't add to the string. You can't add numbers to the numbers and strings together. Okay, so I'm just going to show this list comprehension real quick, and then we'll talk about it. So here's the list comprehension. You see how it has the brackets. I'm creating a list by splitting and taking the first item of every item in the list of lines. And the numbers is casting to an integer the second item for every line in the list of lines. And when I print these, so here's all the letters and here's all the numbers. So let's talk about list comprehensions. A list comprehension is basically a for loop all in one line. And one important thing to remember about list comprehensions, if you remember nothing else, here it is, here it comes. A list comprehension can always be rewritten as a for loop. So these list comprehensions rewritten as for loops look like this. So here's the one I'm saying I want to get all the letters, right, for line and lines. So first I look at the for part of it, for line and lines. That's my for loop, right? I've got an empty list called answer. Now I'm adding to answer. What am I adding? Line.split space item 0, right? Which is this right here. That's the expression that's being evaluated for each item in the iterable and is being added to the list we're creating. Because a list comprehension creates a list. It creates a list by performing an operation on every item in some other list or iterable. So for line and lines, my answer, I'm going to add the results of this expression, which you see when I highlight it here, it highlights it up there because it's the exact same expression, right? And then finally I'm saying letters equals answer, which is the same thing as, like letters equals right here, right? And the second one is the same thing for line and lines. This time I've got a different expression, but we see this is that exact expression. So we're saying for every line, add something to my new list, right? Does a list comprehension make any sense to anyone? Someone in the world it makes sense to, right? But are any of those people in this room? Somewhat, kind of? Go ahead.
Would you say it's always better to make a list comprehension into a for loop? If you were doing like a coding review, would you say it's more efficient that way? Or easier
To use a list comprehension versus a for loop?
Yeah, or to use a for loop instead of a list.
Yeah, that's a good question. Basically, it's important. I will say, as a Python developer, as an aspiring Python developer, it's important to understand like what a list comprehension is at the very base, like what that like you're looking at is a list comprehension, so that when you see someone wrote this code, you're not like, what the heck is that code at all? I don't even know how to look up what that is, right? It's a list comprehension, okay? So then Python programmers love list comprehensions because you could take one list and kind of turn it into another list and then turn it into a third list, and you can do it all with like very little lines of code, right? Because if I'm writing this code seems like it's kind of boring, and it's kind of like, it's just kind of like boilerplate almost, you know, like there's not a lot of information here. It's just kind of building a list and putting one expression as each element of the list. So for people who are used to writing Python and used to reading Python, the list comprehension is actually easier to read than the for loop, right? Because someone might see this for loop and like, okay, they created a for loop. What's it for? What's it doing? Okay, it's going through all of the lines, and now, okay, it's appending, and then you realize, wait, this could have just been a list comprehension, you know? So in situations where you're like taking each item from a list and doing one thing to it, and then like putting it in a new list, I would say yes, it makes sense to use list comprehensions, because that's what your fellow Python programmers are going to expect to see. But there are certainly cases, you can have like nested list comprehensions, for example, and when you start getting into that, or if you start getting into the case where like your expression, like this part, like this is already a bit much. Dot split space slice 0, like that's already a bit, that's probably the most I would want to put in a list comprehension. If you're doing something like, if you see yourself doing something like this, and calculate price item 1, you know, like, then you're like, maybe this should not be a list comprehension. Maybe if I'm doing all this crazy stuff in the expression for the list comprehension, it's like, now it's kind of getting hard to read. So it really, like a lot of things in Python or any programming, it's like at your discretion, you know, to figure out when's the best place to use it and when's the best place to avoid using it. But that's kind of my opinions and what I've learned from Python programming. Does that answer the question?
Oh, yeah.
Any more questions?
That answered it perfectly.
Okay, great, good. So we can use if in a list comprehension, if line starts with A, so we only want the A lines. Notice that here, my expression is just line, right? Like for each item, I'm just putting the same item. I'm not doing anything to it. But why? Because the real work is being done by this if statement, because I'm only putting lines that start with A into my new list created by the list comprehension. So when you see this, when I print A lines, it's just the lines that start with A. And if we did that as a for loop, it would be for line in lines, which we see highlighted right here, right? If line starts with A, which we see right here, right? And then answer append line, which is, this is line. We're just putting the line itself. So, which list comprehensions can be rewritten as for loops? It's a trick question. All of them. Any list comprehension can be rewritten as a for loop. Remember, that was the one thing you had to remember. Any list comprehension can be rewritten as a for loop. And then here is, this is like we were talking about the kind of list comprehensions you might not want to write. Here is a one line of script that calculates the values of all the lines that start with A. So let's look at it. It says for line in lines, so for each line, if the line starts with A, then take the value of that line, the number, the numerical part, right, as casted to an int. And then we're actually going to sum this whole list comprehension. So that list comprehension creates a list of numbers, right? Then we call sum on that list, and we get the total, 270, which is what we got up here. Total for A is 270. Woo! Cool. That's pretty much it. And we're almost out of time anyway. And there is an assignment attached to this lesson. So we want to find the letter that has the largest sum of numbers and print it out. So if you want to do the assignment, what you want to do is put your code in your sfpythonlab.com notebook, write your code there, like test it. The data is in that same directory, so you should be able to load it and like work with it the way I have been. And write the code, and then you want to save your Python notebook. I'll show you that real quick. So when we're in like this notebook, what we can do is file, download as IPynB, the Python notebook, right? So you're downloading your own copy of the notebook that has your code that finished the assignment, and then you can paste it into or upload it into the Python channel on Discord, or you can DM it directly to me on Discord, and I'll look over it and give you feedback. And I mean, putting it in the channel would be great because then we can all kind of see it and like everyone can learn. But if you're too shy, you can just DM it directly to me. Or you can be like all of the students I've ever had in this class and not do the assignment. So.
Travis, I may have accidentally called you a Sith Lord on your own channel.
A what?
I called you a Sith Lord on your own channel.
Oh no. All right, well that is it for the lesson unless we have any other questions. Yes?
First of all, it is awesome that you're doing this, so thank you.
You're welcome.
And I guess I have a question. I don't know if it's the best to ask right at the end, but I know it can be a little challenging to like remember all the definitions, but I suppose that like getting really good at Python comes just with sticking with it and like being patient with yourself enough to say, hey, I can really do this thing, you know. If I put in the hours, this stuff will all start making sense to me, like actually learning a language. And something you brought up 2 or 3 weeks ago was when you're working in a team, whether you want to build something for yourself or you want to take this and get a job with it, or you just want to, I have this cool project I want to build. You mentioned making your code readable and things that make it redundant, things that make it illegible and something that's going to be annoying in like a review. And so I was wondering, are there strategies or ways that you would go about learning so that if someone was working with me, it would be less difficult to kind of, oh, now I have to like go through all this just to understand the code? Or would you say,
Yeah, I mean, one thing you can look up is there's things called style guides. Yeah, so like I remember there was like the Airbnb was like a big popular one like 15 years ago. This is for JavaScript, but there's other ones for Python. So basically this is like the Airbnb JavaScript style guide, and then it tells you like, you know, tells you things like group your shorthanded properties at the beginning of your object declaration, right? So it's telling you like, you have this, but you actually should do this. So there's style guides like this out there. And like a style guide like this is JavaScript, so excuse me for a second. But this JavaScript here, these two code blocks are exactly the same from the programming language perspective. Functionally, they're the same. They have no difference. It's just a matter of style, right? Like, where do you put the variables? What do you name them? How do you put spaces and stuff in places, right? So I would say the short answer is look up style guides. If you want to like study this stuff on your own, read the style guides. But it's also, and you're completely right about like how it's like learning a real language, a human language anyway. Like the more you're in conversation with people, you'll pick up on these things too, right? When you see other people's code, you'll see that, you know, when they write some code, you know, x equals 3, they don't write if x is less than 5 like this, right? They don't write that. They write if x is less than 5, like that. You'll just notice it. You'll start seeing, like, wow, why isn't anyone ever writing that? Because that's just not really good style, right? Like, and it's like, I hope everyone appreciates that. Like, as we're doing the exercises and I'm coming around, I don't care if I see this in your code while we're writing the exercises. Like, I'm not gonna try to nitpick like style things, you know, like while we're doing exercises like this. But that was the question, right? Like, how do I get better at making sure I'm doing like a sensible thing in this situation? And it's like reading code and reading style guides and being in conversation with other programmers. Yeah.
Thank you.
Yeah.
You actually have online comments.
Online comments.
Like it comes up to a notion of what could be maintained by the team. See Gabriel's question, which is always a concern. It is a core discipline of software engineering. So you have online people also participating right now as we speak.
Oh, really?
Oh, okay.
And then he also says that for list comprehensions, things that list comprehensions are not good at. So I think that's like print logger warn, especially in breakpoint. And you see all these comments on Discord. We still haven't figured out the comment thing, but you are live right now.
Okay.
Hypothetically, anyone who's on that link could interact with you, which is comfortable for me because I know how to stream, but still.
Cool. All right. Well, thank you everyone for coming. And I have to say this at the end of every lecture. This class is free. I'm a volunteer. I do not get paid. But Noisebridge runs on donations. So if you feel like you've gotten something out of this course or you want to contribute otherwise to Noisebridge, please look at the links on the walls or go to Noisebridge website, donate links, and make a donation. Thank you.